We're going off book, off record, off script. I didn't want to use the PowerPoint for this one. So, same information though. We're gonna be looking at circuits in series and in parallel. Those are two different types of circuits. We'll explain that later, but there's something that we need to know. And it's Ohm's law. It's this law, and he says the voltage is equal to the current times the resistance of the circuit for the circuit. So the voltage, or the total voltage, is equal to the total current multiplied by the total resistance of the circuit. So if you know two of these, you can always get the third one just by solving, simple algebra stuff. And the simple way, the PowerPoint does it is it says, oh, let's take a look. Let's draw this V, and this divided by, and this is I, and this is R. So you should be writing down all of this, by the way. Anything that I write down, you should write down. Okay, because I'll check these. So if we are solving for V, then you cover up V, and you have I times R. Okay, that's pretty sweet. What about if you're solving for I? Well, then you cover up I, and then you have V divided by R, because it's over. And then if you're solving for R, the resistance, then you have V divided by I. That's just the easy way to remember it. You could get the same things by solving. So like if I solved for I, then I'd get I equals V over R. It's the same thing as solving for it. It's just another way, a simple way to remember, quick way to remember. So, yeah. So, an example for using Ohm's law is a flashlight uses a 6-volt battery and has a bulb with a resistance of 150 ohms. When the flashlight is on, how much current will be drawn from the battery? We can draw this circuit, just have a little diagram. This symbol, you do a long line, a short line, a long line. That is the symbol for a battery. And then the symbol for a resistor is just like a squiggly line like that. So I do that. Sometimes you put a circle around it to denote that it's a bulb, or like a light bulb or something. We'll have the positive end here and the negative end here. The battery is 6 volts. We'll be drawing more of these later, but and that's the total voltage, V sub T. Total voltage is 6 volts. And then we use Ohm's law. I know that the resistance of the bulb is, so the total resistance in the entire circuit, because there's only one bulb, there's only one thing to resist. The total resistance is 150, and if I use this diagram, V I R. Well, what do I want to solve for? It says I have 150 and 6 volts, so that's the voltage. When the flashlight on, how much current will I be? Okay, so I have to solve for current. How much current will be running through the circuit? Well, if I'm solving for current, that's I, so I'll cover that up. So I know now I equals V divided by R. And then I just plug in those things. I equals 6 volts divided by, 150 ohms. And that gives me amps. So I will have, what is that? That's just 0.04 amps. So that's easy enough. You just use that. And there you go. Okay, let's move on. Okay, let's get down to the different types of circuits that we can make. First, there's two ways to make a circuit, and then you can combine them. But like the two basic ways are in series, where everything's lined up in a row, and then in parallel. And we'll look at the properties of each of these things. So I'll put a line there. In series, everything is connected all in a row. So these could be, I don't know, resistors or whatever. But everything, there's only one path for current to follow. So here, if current was flowing through this, it has to go through each one of these, whatever they are, resistors or switches or whatever. There's only one single path for current to flow. In parallel, it's a little bit different. You line up things, let's say like this. It's kind of like they're parallel, but then you can attach more stuff onto here. So there's multiple paths. Maybe I'll do one more. So current could flow down this way and then back to the battery or whatever, or it can continue on, so it can go all these different directions. So there's more than one path. So here we go. Both ends of each component are connected. So this end of the component and this end are connected to maybe the battery or whatever these things are. And then there's multiple paths for current to flow. So that's the difference, and then there's different formulas for each one. So we'll take a look at that maybe in the next video.